Hello students. I am Professor Rutuja Kadam from Symbiosis Institute of Technology. So today we will be learning about fixed point and floating point representation into the computer. Okay. Now the objective of this session is to learn the various methods to represent real numbers in computers. Now, you might have a question that what is real numbers. Now let us see what are real numbers. But prior to that, I want to revise one thing. In the earlier session, we learnt about signed and unsigned numbers. Now what are unsigned numbers? Unsigned numbers are always positive numbers, and signed numbers are the numbers which are positive as well as negative numbers. Now when I say negative numbers, computer is able to store only the numbers which or it can store the information which is in the forms of zeros and ones. So numbers can be represented in the forms of zeros and ones, but this minus sign could not be represented. So three methods were we studied for that. That is sign magnitude, ones complement, and twos complement form. Out of that, we learned that negative numbers can be only represented in one way, that is in their twos complement form. Now let us go to the real numbers. So what are real numbers? Real numbers means it is they are the numbers which are the combination of integer and fractional part. So here if you see these examples such as 2.5 minus 10.06, 0.75 or 101101.1001, these are the random numbers that are taken. And if you observe one common thing between all these numbers, that is there is a decimal point in all these numbers. So we know that 2 and 5, 1, 0, all these can be represented in the forms of zeros and ones. Also in the earlier lecture we found that this minus sign could also be represented. But here the problem is that decimal point could not be represented in computer's memory. Now what to do for that? So two methods were used, or two common methods are used to represent these real numbers in computers. The methods are fixed point representation and floating point representation. Now let us see what is fixed point representation. Now when I say fixed point representation, the radix point or the decimal point is in its fixed position. That means it does not change its place. It is at fixed location. Now if you see this representation, to the left of the decimal point is the integer part, to the right of the decimal point is the fractional part. Now here in this fixed point representation, the number of digits for the fractional part and the number of digits for the integer parts are pre-decided, are fixed earlier. So here if I say that I have, or let us assume that the computer has fixed that for integer parts there would be 4 bits and for fractional parts there would be 3 bits. Now this fixed point representation consists of 3 parts. Which are these 3 parts? There is the sign bit, or it is a sign of the number. That means it can be either 0 or 1. If it is 0, the number is positive. If it is 1, the number is negative. Then we have the integer part. Integer part is after the sign bit and before the decimal point, and a fractional part is after the decimal point. So here just let us take one example. Now here the number is 1001.101, out of which the MSB is 1, which means the number is negative. 001 is the integer part, and dot is the decimal point, and 101 is the fractional part. Now I would like you all people to consider this particular string, and based on that convert this into its decimal equivalent. Now here I have pre-decided that the integer part would be of 15 bits and the fractional part would be of 16 bits. Okay, and sign bit as usually it will be of 1 bit. Now what is the solution? If the MSB is 1, that means the number is negative. Take straight away write minus sign. Now I want you people